So in this segment we're going to continue with our array model using our base 10 blocks, and we're going to focus on prime numbers and composite numbers, and how can we use this model to help students understand what those ones mean. So last segment we were talking about the factors of 6 and the different ways that we can model 6. So one of the ways we came up with was that we could have a 1 by 6 array, and we also came up with the fact that we could have a 2 by 3 array. And those were the only two ways that we could make the number 6. Now let's take a look at some other numbers that we could choose. Let's take a look at the number 2. We've already shown that we can write the 2 this way, but we could also turn it that way. So it's the same array, it doesn't really matter which one it is. And doesn't want to stay straight. And that's one way of making it, and there is no other way of making an array of 2. Let's try the number 8. So one of the ways that we can make the number 8 would be our nice little row of 8, but we could also make an 8 using a 2 by 4 grid. And so there's our 2 by 4 grid, and that also gives us 8. There are no other ways of making a rectangle of 8. Now let's try one that seems simple. How about a 4? And we start off with our nice long row of 4. And the student could say, well, I could also make it with a 2 by 2 grid. And there's my 2 by 2 grid. But some students are going to say, well, wait a minute. You said I can make rectangles, and I didn't make a rectangle. I made a square. Is a square a rectangle? And this is the time that you can have a nice conversation around what are the properties of a square and what are the properties of a rectangle. Lots of students will not think that a square is a rectangle. They'll say a square is a square, and that it can't be the same thing. And this is where you have the opportunity to talk about the distinguishing properties of a rectangle versus a square, and how a square can be a rectangle, but a rectangle cannot be a square. They both have 4 sides, they're both quadrilaterals, they both have 90-degree angles, their opposite sides are both parallel, and their opposite sides are both equal. So that's the definition of a rectangle. However, a square has all of those definitions, plus an additional one of all 4 sides have to be equal. So now you can talk about the differences between a square and a rectangle. But this is technically a rectangle, and so therefore we've made a rectangle with 4 blocks. What about the number 3? The number 3 can be made with a rectangle, and it gives us our nice long row again. And I've just changed our 2 so we can see our pattern a little bit better. So we can make a 2 with a row, we can make a 6 with a row, an 8 with a row, a 4 with a row, and a 3 with a row. But a 6 I can also make a rectangle a different way. I can also make the 8 a rectangle a different way, and I can make a 4 rectangle a different way. But the 2 and the 3 I can only make with my long row kind of rectangle. Now some students would say, okay, well, what about a 5? And they'll notice that a 5 also makes a row. So a logical conclusion would be that the odd numbers are going to make rows, and the even numbers are going to make ones where we can do it with a row or a rectangle. But then you throw the question, what about the number 9? It's an odd number, and it too makes a long row, but I can also make a 9 a different way. I can also make it by a 3 by 3. So that idea of only the odd numbers are the ones that produce rows only doesn't make sense. True, it works for the 3 and the 5, and it works for 7, but 2 isn't an odd number, and 9's an odd number, but I can also make a rectangle. So it's not the odd-even pattern that we're looking at. What we're looking at is the difference between the prime numbers and the composite numbers. Numbers that can only make a rectangle with a row would be a prime number. So 2 is a prime number, 3 is a prime number, 5 is a prime number. But numbers that can make it in more than one way, more than just that row way, are called composite numbers. So 6 is a composite number, 8 is a composite number, 4 is a composite number, and 9 is a composite number. Even though it's an odd number, it's still a composite number because you can make the number 9 in more than one rectangle. And remember, a square is a type of rectangle. So for prime numbers, one way to think about prime numbers is that they can only make the rectangle one way. And composite numbers can make the rectangle in more than one way. That leaves us with a number 1. 1 is a kind of an odd duck, and we're going to talk about that separately here in just a second. Now the number 1 can also make a row, and it can only be made one way. So is the number 1, like the number 2, a prime number? And the answer is no. Here is a better definition for prime numbers. Lots of people say a prime number is a number that only has two factors, 1 and itself. But for the number 1, it's not 1 and itself, 1 is itself. So that's a confusing definition. A better definition might be one that looks like this. A prime number has exactly two different factors. So not only is it just 2, in other words, when I make my rectangle, I can only make it in a row, because that gives me 2 factors, but they have to be exactly 2 factors, because we don't want like the number 4 that has a 1 by 4 or a 2 by 2, so that's got more than 2 different factors, but it has to be 2 different factors. And the number 1 has factors of 1 on one side and 1 on the other side. So they're the same factors. So that doesn't meet the criteria for a prime number. So a better definition for a prime number is a number that has exactly 2 different factors. So 2 works, 3 works, 5 works, 7 works, but 1 does not. 2 does not. 9 does not. So that's a better definition for a prime number, and we can use our area model to help students understand prime numbers versus composite numbers.